think this is a really fascinating question because I think LLMD is bringing in a lot of those types of core features. We're not just looking at the inference layer, which is really what separates it from like VLLM, for example, as a project. We're instead looking at it as the big picture of how does distributed AI work within Kubernetes. And I think to your point, a lot of that is happening at a gateway and an API layer. LLMD is looking at the new paradigm. And that is what metrics are important to an LLM and how does routing now look like? And how does an API also look like when we start moving into that new paradigm? So things like time to first token. So how long does it take for your LLM to actually start giving results? Or token throughput, which is like basically the time between tokens. And those are like two examples, but other ones that we're actually starting to just come up with now, like LLMD is starting to, take note to things like cache hit rate. How often are we hitting the cache of the LLM? That's actually a really critical metric. It can really reduce costs orders of magnitude when you start optimizing around the cache. And a lot of that is happening at this API gateway layer. And what we're doing is we're making the Kubernetes aware of the request. So what we call prompt aware request. So when you're actually making a request to the router, the API, it actually knows where these requests should go. So if you have 3 LLMs configured with LLMD, the example I always give is let's talk about like mixture of experts, for example, where a model over here might be an expert in physics, and this is English, and this is history, for example. The router will be aware if you're asking a question about Albert Einstein and what is E equals mc squared. Well, more than likely, it's probably going to go to the physics section. But because now the router is prompt aware, it can start making decisions on where it wants to route based off of where the expert might be located. If we're talking about like an expert model like DeepSeek, or GPT OSS, for example, where each of those experts are running in their own machine or node within Kubernetes and actually have a significantly higher chance of hitting a cache hit as well.